question has the 4 parts. The part number 1, okay, what is the light energy? Okay, so here we have to find what is the value of the energy of the light. Okay, now what formula we have to use? Okay, here we have the two formulas. Okay, for this one we have one formula. Okay, like this. This is HF. Okay, this is the rule number 1. And because in this problem, okay, the value of the frequency is not given, so we cannot use this one. Okay, so here we have to use the formula, that is the h, okay, the Planck's constant and the speed of the light, and it is divided by lambda. Okay, so this rule we have to use. Now, okay, so if I go for the solution, and this is the solution for the part 1. Okay, so I have to write the formula. Okay, this is E equal to HC over lambda, but here we have to change this the lambda. Okay, it is the lambda is given in the nanometer. Okay, so this nanometer means it is 10 to the power minus 9. Okay, so in this formula, okay, here in this formula there are two constants, okay, and the value of the constants will be given to you in the exam, no need to memorize. Okay, so the h is a Planck's constant, so I am writing the value, it is 6.636 and it is 10 to the power minus 34, and then this is the speed of light, okay, c, and this also will be given to you, the value. Okay, no need to memorize. And this is the value is 3 multiplied by 10 to the power 8, like this. Okay, now, okay, the down I have to write the value of the lambda. Okay, this lambda. Okay, the value of this lambda should be in meter, not in nanometer, not in micrometer, not in millimeter. Okay, so it should be in meter only. So, okay, so 1 nano, okay, so the value of the 1 nano, okay, it is n, 1 nano, okay, 1 nano is 10 to the power minus 9. Okay, so this is 589, so I need to multiply. Okay, so I need to multiply by minus 9, so then it will be in the unit of meter. Okay, like this. So the answer will be, okay, the answer for this, okay, it will come 3.37. Okay, so this will be 3.37 and 10 to the power minus 19. Okay, this is 10 to the power minus 19. So this is the answer. Okay, this is the answer of the energy of the light, okay, in joule, in the unit of the joule. We can change this in the electron volt also. Okay, this is up to me, or this is it depends upon the question also. Okay, if they are saying like find the answer, okay, of the energy in the joule is a standard one. Okay, so you have to find in the joule, but if the question is saying, okay, sometimes the question may say find the value of the energy in the unit of the electron volt. Okay, in that case, okay, you need to change. Now, the point number 2, okay, the point number 2 is we have to find, okay, we have to find the electron kinetic energy. Okay, so here we have to find electron kinetic energy. So we have, okay, 2-3 rules, okay, for the kinetic energy, and so we have to look which rule we have to use. Okay, the one rule, okay, the one rule for the I am writing the rule here. Okay, so the rule is like this. Okay, the one rule is okay, the one rule, okay, the one rule I am writing the rule here. Okay, the one rule is like this. Okay, the E equal to, it is the charge of the electron and the stopping potential. Okay, this is rule number 1 rule. Okay, and the other rule is, okay, the other rule is the kinetic energy equal to, this is half and it is mv square. This is another rule. Okay, and there is a one more formula, okay, that we are going to use here. Actually, this rule I cannot use because insufficient information is given, and this also, okay, I cannot use. Okay, so here we are using the photoelectric equation. Okay, so I will take the value of the Ke from there. This is the photoelectric equation. Okay, photoelectric equation. So the photoelectric equation, what is the equation? The equation is the E equal to kinetic energy and then plus, and this is a work function. Okay, this is the rule, or this is the formula, okay, for the photoelectric effect, or like that. Okay, this is given by Einstein. So here I am going to use this. Okay, so why? Because I have the value. Okay, I have the value of this. I will take this. I will take this. Okay, this is I have already. Okay, and here it is given. Okay, the work. This is the value of the work function. Okay, this is the value of the phi. So I have this. I have this. Okay, so I will find this. Okay. So I am writing the formula. Okay, I am writing the formula. Okay, like in this way. Okay, the kinetic energy is equal to the energy of the light minus this is the work function. Okay, so how many values we are writing here? So all the values should be in joule. Okay, not in electron volt. Okay, so electron volt means if you are writing the value of this energy, okay, this energy in joule, and here also you are writing in joule. Okay, so you will get the answer in joule. Okay, for example, you can write electron volt also, there is no harm. Okay, but if you are writing, okay, if you are writing the value of the E, okay, in the unit of electron volt and the value of the phi in the unit of electron volt, then you are going to get the answer for the kinetic energy in the electron volt. Okay, so it will be same like this. Okay, and this is same like this. Okay, if you are using a joule, so all should be joule, and if you are using a electron volt, so all should be electron volt. Okay, it is like this. Okay, so but here I am using, okay, my planning is to use the joule here. Okay, my planning is to use, okay, and my planning is to use the joule. So the value, okay, the value of this E, okay, I will take from here. I will take from, this is the value of the E. Okay, and this value is 3 point, this number. Okay, this number. Okay, so this is 3.37. Okay, so this is 3.37 and multiply by 10 to the power minus 19. Okay, now the value of the work function. Okay, but if you see here, the value of the work function, okay, if you see, okay, I am erasing something. Okay, so if you see here in the question, the value of the work function is given in the unit of electron volt. Okay, so now if you see this, okay, this is the value of the phi, the work function. Okay, this is a work function, but it is given in the unit of, this is 1.2 electron volt. So I need to change, okay, this electron volt to joule. Okay, so I am writing here, okay, this is 1.2. okay, then I need to multiply by 1.6, okay, multiply by 10 to the power minus 19. Okay, so I will get the answer for this. Okay, I will get the answer for this around okay. So after the calculation, I am getting the answer, okay, in my calculator. This will be, okay, this will be 1.45 multiply by 10 to the power minus 19, and this is the value, it is coming in joule. Okay, so this is the answer for the kinetic energy, okay, of the photoelectrons. Now, okay, so what is the part number third? Okay, so we have to find the stopping potential. The stopping potential is denoted by V naught. Okay, so here I am going to use this rule. Okay, so this is the relation between the kinetic energy and the stopping potential. Okay, so for the part number, okay, for the part number 3, okay, I have to find what is the value of the stopping potential. Okay, this one. So for this, okay, so for this I will write the formula. Okay, this is the kinetic energy equal to the charge. Okay, this is the charge of the electron and multiply by the stopping potential. Okay, so here I have to find the stopping potential, then this will be equal to kinetic energy and divided by the, this is the electronic charge. Okay, so here already I calculated the value of the kinetic energy, so I will write here this will be 1.45 multiplied by 10 to the power minus 19, and this is a charge of the electron. Okay, so this is 1.6 into 10 to the power minus 19. Okay, so this will be cancelled out. Okay, this will be cancelled out, and if I divide this, okay, this will be cancelled out, and if I divide this by, okay, this by 1.6. Okay, so this will give me the value, okay, 0.9. okay, because as I told you, okay, as I told you, this, the name of this is a stopping potential. Okay, because when I say, okay, when we are saying this is a potential, okay, the unit of this stopping potential, okay, the unit of the stopping potential is a voltage. Okay, this is a voltage, and the unit of the voltage is always volt. Okay, so the value of, this is not a voltage. Okay, so the voltage is it will come like this. This is a unit. Okay, so the value of the stopping potential will be 0.9 volt. Okay, so this is the answer of the, okay, the part third. Now, okay, so there is a part, okay, there is a one more part, the part 4. Now they are asking, okay, now they are asking what is the cutoff wavelength. Okay, so the cutoff wavelength or the threshold wavelength. So how we are showing the cutoff wavelength? We have to find, okay, we have to find the value of the lambda naught. Okay, basically this lambda naught is connected, okay, with a work function like this. Okay, work function. So I will write the formula. Okay, I will write the formula for the, okay, so this is the part number 4. Okay. Now this is a part number 4, and okay, this is the part number 4. Now they are asking what is the cutoff. Okay, what is a cutoff? Okay, what is a cutoff wavelength? The cutoff wavelength is denoted by lambda naught. Okay, so basically this is connected with the work function. Okay, it will come in the work function formula. So I am writing, okay, so this is the work function formula, and this is the H, okay, multiply by C, and this is lambda naught here. Okay, so I need to find this. Okay, so I can do like this. Okay, so this is lambda naught here, and this is equal to the Planck's constant multiplied by the speed of light, and this will come the work function here. Okay, but work function I have to use the value of the work function in the joule, okay, not in the electron volt. Okay, if you see here, this is the value of the work function, but it is given in the electron volt. Okay, 1.2 I cannot use. Okay, so here I am writing the value of these two. Okay, these two factors. This is the value of the H. Okay, it will be given to you, it is a constant, and I am writing it is 6.636 multiplied by 10 to the power minus 34, and this is 3 multiplied by 10 to the power 8. Okay, speed of light. Now here, okay, I need to write the value of the work function in the unit of joule. Okay, so I need to multiply this by, this is lambda, not lambda. Okay, see, there are two in this chapter. Okay, see, in this chapter we are using, okay, two lambda. The one is this lambda and the other is this lambda naught. Okay, we are using the frequency and also we are using the f naught. They are not same, they are different. Okay, see, now when we are saying like this is the metal, and on the metal the light is coming. Okay, so this is the light, the light is coming like this. Okay, so here the lambda. Okay, so when I say the lambda, so this is the wavelength of the light. When I say the frequency, so this is a frequency of the light. So this and this, okay, this is connected with the, okay, this is connected with the light, okay, which is incidenting on the metal. Okay, but when I say the lambda naught, and when I say the f naught, this is connected not with the light. Okay, this is the property of the, okay, this is the property of the metal. Okay, related to the metal. Okay, so this is related to the metal. Okay, related to the metal means, okay, what is the meaning? The related to the metal means it is related to the work function. Okay, it is like that. Okay, so the meaning is the lambda is different and the lambda naught is different. They are not same. Okay, they are different. Okay, they are not same. So here, okay, we have to find the value. Okay, here we have to find the value of the lambda naught. Okay, so I need to write here 1.6, okay, 10 to the power minus 19. Okay, so the value of this lambda naught will come, okay, so this will come around 1 point, okay, this is 1.036, okay, multiplied by 10 to the power minus 6 in the unit of meter. Okay, in the unit of meter, this is your answer. But sometimes, okay, but sometimes this is a standard unit. Okay, but sometimes, okay, most of the time the question may say, okay, find the value of the lambda, okay, in nanometer. Okay, so you have to change the meter to the nanometer. Okay, so here I am writing one rule. Okay, if you are changing, okay, if you are changing nanometer, okay, nanometer to the meter, okay, nanometer to meter, then you have to multiply by 10 to the power minus 9. Okay, but if it is the opposite of this rule, opposite of this activity, means you are changing meter to nanometer, opposite to this. Okay, opposite to this, then you have to divide. Okay, then you have to divide by 10 to the power minus 9. You have to divide. Okay, so if I want to change to nanometer, so what I need to do, I need to divide, okay, by 10 to the power minus 9. Okay, so in this case, if I am solving, okay, so this will come 1036 nanometer. So the answer will be nanometer like this. Okay. Now the question number 5. Okay, so here they are asking what is the longest. Okay, what is the longest wavelength? Okay, what is the longest wavelength? Longest wavelength of the radiation that can eject the photo electron from potassium. Okay, potassium is acting as a the metal from the surface from which the electrons are coming out. Okay, what it is given to us, the value of the work function given to us. Okay, so this is the value of the phi. Okay, it is given 2.24 okay electron volt in the unit of electron volt. Now they are asking what is the value of the wavelength. So actually this wavelength is a cutoff wavelength basically. Okay, so this is basically a cutoff wavelength. Okay, so now if I find the solution of this, okay, so I need to write the formula for the work function. Okay, phi naught, and the relation between the phi naught and the lambda naught. Okay, HC, and this is lambda naught. Okay, so I need to find this lambda naught. Okay, the wavelength. So this will be HC, and this will be phi naught. Okay, so I'm finding I'm writing the value here. So this will be lambda naught, and this is 6.636 10 to the power minus 34, and multiply by 3. Okay, 3 10 to the power, it is 8, and it is divided by it is divided by the value of the work function, this one. Okay, but this should be in the unit of joule, not electron volt. Okay, so this I need to change this. So this will be 2.24 multiplied by 1.6 into 10 to the power minus 19. Okay, so this way we can change the value from electron volt to the joule. Okay, and the answer will come after the calculation. So this will be 5.5 5.554 and multiply by 10 to the power minus 7, and this is meter. Okay, so this is the longest wavelength. Okay, so this is the answer of the longest. Okay, actually this is a cutoff wavelength. Okay, basically. Okay, so this is a longest cutoff wavelength, value of the longest cutoff wavelength for the potassium. This is your answer. Okay, now so here they are asking find the maximum velocity. Okay, so we have to find the value of the velocity. Okay, value of the velocity of the photoelectrons ejected by 80 nanometer. Okay, so this 80 nanometer, this is the value of the wavelength of the light, and if the work function of the photoelectron is this. Okay, so this is the value of the work function. Okay, it is given in 4.73 electron volt. Okay, this we need to change. Okay, so what they are asking the maximum velocity. Okay, so this maximum velocity, this will come from where? This will come from the formula of the kinetic energy. Okay, so kinetic energy formula, that is half mv power 2. It will come from here. Okay, so this will come from here. Okay, so if I write the formula for the kinetic energy, this is the mass. Okay, this is 1/2. This is the mass. Okay, mass of what? This is the mass. This is a mass. Okay, but mass of what? This is a mass of the electron. Okay, this is a mass of the electron, and this is the velocity. Okay, like this. So this formula we have to use. Okay, now I need to so mass. Okay, mass is a constant number. Okay, I know, and we need to find the value of the V. Okay, but I need okay, I need what is the value of this kinetic energy. Okay, so for this purpose, okay, for this purpose we have to use, okay, we have to use the equation, okay, the photoelectric equation, and this is the E equal to the kinetic energy and plus this is the work function. Okay, so this equation we have to use to find the value of the kinetic energy. This I need, okay, this I need. So if I write, okay, so this is coming E and this is coming kinetic energy and plus this is coming phi. Okay, now, okay, so this E stands for, this is the energy, okay, this is the energy of the light, okay, this is the energy of what, this is the energy of the radiation, okay, and this radiation is having a wavelength of 80 nanometer, okay, the value of the lambda, okay, given. Now, so I need to write the formula which is related to the wavelength. So this is h, okay, c and divided by it is lambda, okay, so this is equal to kinetic energy I need to find, okay, so and the work function is given to me, okay, this is given, okay, so easily I can find the value of this, okay. So if I am writing like phi naught, okay, this is a phi, not phi, okay, phi is the angle, okay, so it is a phi naught, okay, like this, phi naught. Okay, so this will be, okay, phi naught and this is hc over lambda and it will be, okay, this no, this will come here, okay. So okay, so I am, you know, moving this, or I am moving this, okay. So okay, so one side, okay, so one side I am, okay, I am not moving this, okay, I am moving this to the other side, okay, so it will be, okay, minus to the other side, so this will be phi naught and this is the value of the kinetic energy, okay. So here now I will write all the values, okay. So the value, okay, first I will write the value of the h and this will be 6.636 and 10 to the power, okay, minus 34 and this will be 3, okay, multiplied by 10 to the power 8 and it will be divided by, okay, lambda. But this lambda, okay, so the value of the lambda is given in nanometer, okay, this is nano. So this is, you know, here, okay, as I told you, okay, as I told you, you are changing nanometer to meter, okay, so you have to multiply here, okay, so I need to multiply by 10 to the power minus 9, okay. So this information what I have written here, this is the value of the hc over lambda. Now minus, okay, so this I need minus, okay. So now I am going to write the value of this, okay. So it will given 4.73, okay, so this will be, I don't have the space, so I am writing it down, okay. So this will be minus, okay, this is, okay, so this is minus, okay. Now this is minus, okay, this minus, okay, this minus. Now after that, okay, after that it is 4 point how much, no 73, okay, so this will be 4.73, not 3, and this number, okay, 4.73. So this will be 4.73 and I need to multiply by, okay, 1.6 into 10 to the power, it is minus 19, okay. Now this the answer, okay, so the answer will come for this, the answer for the kinetic energy, okay, in joule, after the calculation it will come 1.73, okay, 1.73 the answer, the calculation of this. Okay. Okay, the calculation of this will come 1.73 10 to the power minus 18 joule. So this is the value of the kinetic energy coming. Okay, this is the value of the kinetic energy coming. So okay, so the value of the kinetic energy, okay, in joule, I found the value of the kinetic energy. Okay, this is 1.73 10 to the power minus 18 in the unit of joule. Okay, this I got now. So I know, okay, so I know the formula for, okay, I know the formula for the kinetic energy, which is, okay, which is kinetic energy half, and this is the mass of what? This is the mass of the electron. Okay, I am writing like this. Okay, so this is the mass of the electron, and this is the velocity of the electron. So I need to find this v. Okay, so what I will do, I will write here, okay, I will take the v square one side, okay, so the 2 will go to the other side, okay, this is 2 multiplied by the kinetic energy, and this will go to the other side. So this is coming like this. Okay, but here this is coming the value of the v power 2, v square. Okay, we don't need a v square, we need a v. Okay, so the v is equal to okay, so I need to cancel this square. How I can cancel? I can cancel if I keep all the things in the square root. Okay, so this is coming here and this is coming here. Okay, so now after that I will put all the values, okay, in this square root, and it is 2, okay, multiply by the value of the Ke, okay, this one, and this will be 1.73 multiplied by 10 to the power, it is minus 18, okay, and divided by the mass of the electron. Okay, so as I told you, the mass of the electron is a constant number. Okay, it will be also, this also it will be given in the exam. Okay, no need to memorize. I know. Okay, so I know, so I am writing. Okay, and the value, this is a value of the mass of the electron. Okay, the mass of the electron is 9.1. Okay, this is 9.1 multiplied by 10 to the power, it is minus 31. Okay, this is minus minus 31 in the unit of kilogram. Okay, in the unit of kilogram. So here, okay, so if we calculate, okay, this the whole thing, the answer it will come for the velocity, this will be 1.95. it is a very big velocity. Okay, it is 10 to the power, okay, 6 in the unit of meter over second. So this is the answer, okay, for the velocity. Okay, so this is the velocity of what? This is the velocity of the electron or the photoelectron.